Welcome, chapter 12, part 1. So far we have done some fundamental programming of the IT51 microcontroller in assembly code, and then we did some understanding of the computer architecture, the microcontroller architecture and the registers. So, hardware side, we have discussed a lot. But now in chapter 12, we will try to apply our basic knowledge to interface the hardware with the microcontroller. So the hardware could be, so this part is the interfacing. So the hardware could be a switch that needs to be connected with the microcontroller, a sensor. It can be a multiple of switches, more than one switches. That can be a keyboard. It can be interfaced with the LCD displays, with the 7 segment displays, with the DC motor, with the AC motor, with the relays, blah blah blah. There could be many things. So we start. So now this time is the application of the microcontroller, where we can use the microcontroller. So this part, that chapter 12, is about the interfacing, and we will interface first the keyboard with the microcontroller. So this topic is part one, interfacing keyboard with IT51 microcontroller. So before going ahead, some fundamental concept of digital switches. So we have to go through this one. Probably, I assume all you know about this thing. We must have to understand, must have to go through this basic understanding of the switches. So now, for example, if we have this circuit, in this circuit, a supply of plus 5 volt is connected with this wire, and a switch is placed here. And if this is your output, if you are measuring, if you want to know what is the voltage level at this point, we can understand this voltage level will be high, because this line is directly connected to the supply voltage via a resistor. So this high voltage will appear here. And because this switch is not connected with this terminal, so no effect of this grounding or of this switch. So D0 output will be 1. That's very clear, it's straightforward. Now if we press the switch, if we press this key, what will happen? The value at this point will be 0. Why it will be 0? Although it is directly connected with the plus 5 volt via resistor, but this is the shortest path of the loop, and we can see this point is directly connected with the ground. So this, at this point, the potential will be 0. So we can see the D0 will be 0. This is the basic understanding, and we will try this knowledge to understand the interfacing of the keyboard. Let's take another example. This is also a simple example. In this case, suppose if you want to know the voltage at this point, at this terminal, when the switch is open, the voltage at this terminal will be 1, because yes, this is directly connected with the 1. What happens if we turn on the switch? If the keyboard is pressed, then what will happen? The plus 5 volt is also connected to this point. Plus 5 volt is also connected to this point. Okay, this is why the resistor, but this is why this is the shortest path. So the shortest path is still connected with the plus 5 volt. So here the output voltage will again be 1. So voltage will not be changed. These are the basic understanding about the these are the basic understanding that we must need to know to understand very clearly the keyboard interfacing with the microcontroller. Now move to the next. Let's suppose if we have a key, if we have a push button, this is one of the key, and if we want to interface with this, if we want to interface this key with a microcontroller. Of course, we cannot connect this switch directly to the microcontroller. The microcontroller provided a port, so out any external device can be connected with the microcontroller via the input output port. Why the ports? So ports are designed for this application. The ports are designed for the interfacing of the microcontroller with the external devices. So okay, if we connect this, if we have one switch, we will connect with P1.0. It can be any other port, but we are assuming that if we, so in order to connect a switch with the microcontroller, what we need a switch and one wire, and we need a one bit of a port. Okay, that's fine. We can connect this one whenever this switch is not pushed. So this value will be 0 because this is grounded, and whenever this switch is pushed, so this value will be 1. It's okay, fine, there is no problem. Now if we have two switches, what will happen? The second switch also need one wire to connect with one more port. If we have three switch, so the third switch also need one more wire to connect the one connect another bit of a port. What happens if we have four? It's same. So the logic here is, if we want to connect four switches, then we need a four wire and of course the four bit of a port. What happens if we do something more? For example, if we have more switches, then what will happen? More ports will be required. For example, let's suppose if we have not four switches, we have let's take let's take 100 switches. If we have 100 switches, so how many wires we will require? We will require 100 such wires. And how many bits we will require? We will require 100 bits. That is not a rational value. That is not a good idea. That in order to connect 400 switches, we need 100 wires. That's not a practical. That's not a good idea. It's very large number of wires, and also we need 100 bits, 100 bits of a port. So it's not a good idea. So in order to get rid of this problem, we take the support of a matrix. And what is matrix? For example, if we have one wire, the second wire, and the third wire, we have four wires. How many wires? We have four. And we can make a matrix using, so these are the horizontal wires, row 1 2 3 4. And if you make columns, second column, third column, and the fourth column, so how many wires? Here we have four rows and four columns. Total how many wires? 8 wires. Okay, so in this case we used 8 wire, but how many switches we can connect here? If we take the junctions, so if we connect each switch at each junctions of this matrix, so how many switches we can connect? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So there could be there could be possibility we can connect total how many switches? 16 switches we can connect. And how many wires we need to connect these 16 switches? We need to connect 4 plus 4, only 8 wires. So remember, 8 wires in the form of the matrix can accommodate 16 switches. That is the efficient way. Okay, and let's exaggerate this one. Let's suppose we have 10 rows and 10 columns. How many wires we need? 10 rows plus 10 columns, 20 wires we need. And then how many switches we can have? 10 multiplied by 10 means 100. So 100 switches we can install in the matrix. 100 switches we can accommodate in the matrix by just having 10 plus 10, 20 wires. So these are the economical and the efficient way. That's why the keyboard is designed in the matrix form, is not in this such a linear form. One switch, one wire. No, that's not a good idea. So so the now we know why the matrix is important in the interfacing of the microcontroller with the keyboard or the keypad. Okay, so this is the benefit, and now we move to next. So move to the our original topic. So let's assume we have four column, one column 0, 1, 2, 3, and each column is connected via resistor, pull-up resistor with the plus VCC, and each column is connected with one bit of a port. So port 2 bit 0, port 2 bit 1, port 2 bit 2, port 2 bit 3. So how many bits we use? 4 bits used for the four columns. Okay. So what will be the value at this point if you want to read the value at this area? What you suggest? Will it be 0 here or it will be 1? It will be 0. It will not be 0. It will be 1. Why it will be 1? Because this point is directly connected with the plus VCC. So this is one value, and the same is for this one. Same is for this one. So all these values will be 1, 1, 1 when we connect four wires with the supply. Now let's suppose we want to connect four more wires, but these four wires are the horizontal wires. So these are the rows. So how many we have rows? 1, 2, 3, 4 rows. And remember, these each of these rows are just independent. This is just one wire. This wire is not going to connect. This wire is not in connection with any of the row, any of the columns. So these columns and these rows are independent. I can show you why it are these are independent. You can see it now. So in such 4 by 4 matrix, so what is the matrix here? One junction, two junction, three junction, four junction. Okay. So in such 4 by 4 matrix keypad, there is no direct connection between rows and columns. Remember, these rows has no connection with the columns. How I can demonstrate it? Please see it. So you have seen again one more time. So you can see neither of the rows is connected with any of the columns. So these columns and rows are independent. They have no any connection with themselves. Okay, this is very clear. Now if we connect the supply here, so what will be if you want to read the value here, what will be its value? It will be 111 because this wire is connected with the supply, same supply. So we can have 1 values. Okay. So now the situation is we have 4 by 4 matrix, and in such case, if we have not installed any switch or not, so in such case, the if we want to read the value here, it will be 111, and if you want to read the value here, it will also be ones all. Okay. Now make port 1 output port, port 2 input. Port 2 input means read by microcontroller. So this value will be read by the microcontroller. So this one is the input port for the microcontroller. Okay. So these value will be read by the microcontroller, and these are the output port in the sense that microcontroller will send value here 0, can send here value 1. So okay. So these, please remember, this port 1 is the output port and port 2 is an input port. In order to understand this one, be careful. So what is the input port? Input port means we can read the value at this point. What is the output port? We can send, the microcontrollers can send value 1 or 0 at this port. We will not read this value. Okay. So this is the difference between the output port and the input port. Let's move ahead. So okay, what is now Which is now because these are the output port, and we are now assuming the microcontroller is sending at all these ports is sending one value. So here port will be here all the bits will be one. Under such condition, if we want to read this value, what is the value here? What we should read? We will read 111. Why? Why it will be 111? It is not because these are the 111, so this will be 111, because now so far we understand that this column is directly connected with this one. This column is not connected with any of the rows, so these are the independent column, so it will not have the effect if we send 111 value. So it will not have, it cannot change the value at here, because these are not these the columns and the rows are the independent, they are not connected. So how we can make connection of the column with the rows? In the slide we suppose if the output is 111 here, and if we connect a switch here, this is a keypad, this is a key, we will call it key, so this is the key 0. So if we install key 0 here, what will be value, what the value we will read here? Hmm? Will again we will read value 1. Yes, this value will be 1. Why? Because the switch is installed but the switch is not pushed, so it has no connection with the column or with the row. So this one is directly having the supply voltage. The supply voltage is directly connected with this one, so this will value 1. Similarly, this will value have also 1 1 1 1. Okay, now move. Contact between a row and a column is only possible when a key is pushed. That is right. If we connect all the switches, if we install all the keys and none of the switches pressed, so there will be no change. We always have the microcontroller will read always these always 1 1 1 here. Okay. How if so, so if you now want to push the switch, let's suppose, okay, I animated it and now it looks, and now the switch key 0 is pushed. What will happen now? Will this value change or not change? Let's let us analyze very carefully. When we push this switch, it means this value is 1 and this value 1 is connected with this value 1, and here will be 1. So there will be no change. The value is still 1. Okay, that's strange. Now move to the next. Okay, so what we have seen, even if we press this switch, the status is not changed here. Microcontroller will read 111. Okay, now we change what we did here. We are moving this 11 value and we make this value 0, because this is output port. We can set bit, we can clear bit p 1.0, then this value will be 0. Now analyze. Okay, still we have the switch which is pressed. So what will happen? Now the switch is pressed, so this 0, this 0 directly connected with this wire switch, and this 0 will appear here. So now p 2.0 will no longer be 1, but it will change from 1 to 0, and you can see it now becomes 0. Okay, now for the second switch, the switch is not pressed, so still it will have value 1. Okay. But the moment if we, okay, so we remove this switch, and this will become 1, and now we connect, if we, before pressing the key 1, this value is 1, and if we press this value, so what will happen now? The 0 is connected directly via the switch to this port, so this port will no longer be 1, this bit will become 0. That's good. So what we have seen, if we in this scenario when the the P1.0 was set to 0. If we press switch 0, then bit 2.0 becomes 0. If we press switch 1, then bit 2.1 becomes 0. And continue, if we continue this one, so we will see if we press this one, so this switch will be 0, and that's clear. Now if we do for this third key, so third key will also become 0, and the moment if we remove this switch, this will become 1. So now the understanding is that if we set P1.0, oh sorry, if we clear P1.0, or if we make P1.0 0, then any of the switch either 0, 1, 2, 3 is pressed, then corresponding column value will become 0. As we see, if the third switch 3 is pressed, then the corresponding column P2.3 will become 0. This is a good point, because we are now able to check which switch is pressed. For example, if this becomes 0, it means we will say, okay, the switch 0 is pressed. If this status is 0, then we will say, okay, switch 2 is pressed. So now we are at least able to say out of 4 which switch is correct. If this becomes 0, it means switch 1 is pressed. So we have this understanding. Okay, now we move up. Now we move onward. So P2 reads all ones if no key is pushed. Okay, this key, none of the key is pushed. But the P1.0 still has value 0, but none of the switch is pressed. So it means P2 is reading 0. P2 is reading 1. All its bit has ones. Okay. So only the bit will become 0 if we push the switch. Now, so I have to before rewinding, I have to rewind it. So keep P1.0 equal to 0. If we place this one value 0, switch 0 changes 2.1. Switch 0 changes 2.1. Switch 1 changes 2.0. Sorry, switch 0 changes 2.0, and any of the switch is pressed, the corresponding column will change. Now, so if we for now we are connecting the rest of the switches in this. So let's suppose what is here. If we make this one 0, now this time we are also making P1.10. So this switch 4 is connected. What will happen? Its value is not changing because this value is 1. What happens if we press switch 4? Then the 0 is directly connected with this bit, and this bit will become 0. That's good. Now if we move to ahead, so we can see if this is pressed, this become 0, and if we move ahead, so if switch 6 is pressed, then the corresponding column will become 0, and similarly the switch 7 is pressed, the corresponding column 2.3 will become 0. So what we understand here, that good thing is that if we press 4, 2.1 will become 0. But what happens if we press second time 0 key? If we press, because this is also 0, if we press 0 key, then for 2.1, 2.0 will become 0. Or if we press switch 4, this will also become 0. So we don't know. We know that if this value is 0, it means either of this switch 0 or either of the switch 4 is pressed. But which one is pressed, that I don't know. You can only say, okay, if this is 0, it means either this is pressed or this is pressed. Okay. So we want to, the next task is we have to identify. Okay, if this is 0, it means we can say that one of the switch along this column is pressed. But this is not enough. We want to know, at least for this scenario, we want to know either the 0 switch is pressed or the 4 switch is pressed. So this is the next task. So I will try to explain this one now. So move to the next. So keep P1.0 as we said before, and if we install all the 16 switches from 0 to 1 2 3 4 5 6 7 8 9 A B C D E F, so total 16 switches are installed now here. So, and what we are doing, we are also making all these rows set to 0. So what will happen? Let's take this example. If the switch 0 is pressed, this will become 0. Okay? If this is pressed, this one again will become 0. If switch 8 is pressed, 2.0 will become 0. If the switch C is pressed, so it's good that if this one is 0, it means any of out of 4 switches is pressed. But which one is pressed? Either 0 is pressed, 4 is pressed, 8 is pressed, C is pressed. We don't know. By only knowing this value, we don't know. What we know, if any of the port of the input port reads 0, it means either of the switch. It means any one out of 4 switch to 6A is pressed, but which one is pressed we cannot say by knowing only this value. Okay, so this is our next task, to identify out of 4 which one is pressed. Okay, so now the conclusion is that if any one or all the rows are set to 0, all the rows are set to 0, a key is pressed, one of the column will have 0, since the key pressed provides the path to the ground. Any of the sprites path to the ground, 0. So now set all, okay, we already set all rows 0. Okay, okay. Now we take a new scene where all the rows are set to 0. So if switch 0 pushed, okay, we already have discussed this thing. So so if 0 switch is pressed, so 2.0 will become 0. That's good. If switch 2.0, if switch 4 is pushed, if switch 4 is pushed, then again 2.0 will reach 0. If switch 8 is pressed, then again 2.0 will reach 0. If switch C is pushed, then again this will 0. Okay. Now set all rows to 0. So we can see here. So set all rows 0. So if switch 2 is pushed, switch 2 is pushed, this will become 0. If switch 6 is pushed, this will become 0. If switch A is pushed and switch E is pushed, as we have explained it already. So similarly, okay. So the task is, we know, if by knowing one of the bit 0 of the column, we know that one of the switch is pressed. But the next task is which one is pressed. How we can manage it? We have to manage this thing. Okay, how we can manage? But we need to know, if all the rows are set to 0, then pushed switch column is none. but we need to know to which row switch belongs. If each row is set to 0 one by one, then we can get both the columns and row of the push switch. So what it says that instead of making all these 0, we will make one bit 0 at one time, and then this we will make 0 second time, this we will make 0 the third time and the fourth time. Okay, so in sequence we can make one by one each of the row to 0, and then we will read the value here. For example, if we make this row is 0 and we press this button, then this value will be 0. And what it indicates, this value 0 indicates that that either of the column is 0, either the switch 4, either the switch 4 048C is pressed. But this, under this condition, we have only 0 value here. So it means this is the only switch which can provide 0 value to the 2.0. So that means it is confirmed that if under this condition, if 2.0 is 0, it means it confirms that key 0 is pressed. Okay, now move to the next. Okay, if we press button 1, then this will become 0. Is it okay? Yes, it will become 0 because this is we set 0, and all the values are 1 and none of the switch is pressed. Even if this is pressed, okay, let's see. If this one is pressed, what will happen? By pressing this one will travel to here. So this will be 1. So even if this is pressed, no effect will be at this port. If this is pressed, no effect will be at this 2.1. It will still remain 1 because the rest of the things are 1. But if we place here 0 and key 1 is pushed, then it means this ground, this 0 value will make 2.1 a 0 value. Okay, so this confirms that if under this condition, if 2.0 is 0, it means switch 1 is confirmed. It cannot be switch 5, it cannot be switch 9, it can't be switch D. Okay, so now we move ahead. Similarly, I done this one. You can see here it is again 0, and then if you press this one, so this can be 0. Now the next step is to make 2 p1.1 0. So we make it 1 and we make this one 0. And under such condition, if this switch 4 is pressed, it means this will become 0. If switch 5 is pressed, this one will become 0. Switch 6 is pressed. Sorry. Under this condition, we know any of switch 4, 5, 6, 7 is pressed, then we can see the changes in the rows in this column. So now if we make uh, this one 0, so what we are doing, we are making row 1 0, and then row p1, row 1 0, row 2 0, and now we are making row 3 0, and then next we will make row 4 0. If row 4 0 is pressed, if row 4 is 0, it means if you press this one will be 1. If you press this one will be, sorry, if we keep p1.30, then if the key C is pushed, then this will become 0. The D is pushed, this will be 0. E is pushed, this will be 0. And F is pushed, this will be 0. So what we understand, now we completely know which switch is pressed. So the procedure is that we always make each row 0 one by one. For example, let's take a neutral point. We are here, we are standing here, and someone comes and he or she press switch 5. So how we will know? The microcontroller is changing this one 0, then this one 0, this one 0, this one 0. When the microcontroller change this value 0 and the switch 5 is pressed, what will happen? The microcontroller makes this one 0 and this one is not pressed, so there will be 1. And if this one is pressed, then this will also be 1 because this one is not 0. When the next time microcontroller makes this value 0, then we will know, okay, this value is 0 and the switch 5 is pressed, then it means that 0 is from this switch directed to 2.1. So under such condition, we can identify which switch is pressed. Now the question is, it looks like that microcontroller will first perform this one 0 and it will scan all the switches, and then it will make this one second row 0, and then again it will scan this one, and then microcontroller, for example, switch F is pressed. For example, switch F is pressed. What the microcontroller will do, first it will make this 0 and it will try to see if any of the switch is pressed. Of course, we will not see any changes. Then this one row will become 0. We will not have any change because none of the switch is pressed. And if this one is 0, then nothing will change. But if this one is 0, because we are assuming that the switch F is pushed, so this one will become 0. It looks like it's a slow and time taking process, but it is not, because the microcontroller command works in microsecond, maybe in nanosecond, new microcontroller, but it's okay, microsecond. And when if someone push the switch, it can stay at least 5 millisecond. The shortest state could be 5 millisecond or 10 millisecond. So so micro so this switch will remain closed for much longer time than this scanning time. This is scanning time maybe 10 microsecond, but this switch will stay pushed for 5 millisecond at least. So in this way, this remains 5 millisecond pushed when human pushes this switch, and in this 5 millisecond time duration, microcontroller will scan all the, will make this one 0 0 0 0, and will know which switch is this. This performance, this task can be performed in maybe in few microseconds. So there is no time issue. Okay, now find which key is pushed. Okay, this is the next slide. Okay, we done this one. Hmm. Find which key is pushed. Okay, this is the question. Find which key is pushed if rows are set to 0 1 1 0. Where is rows 0 1 1 0? Okay, rows value is 0 and the column value is set 1 1 0 1. So column value is 1 1 1 here. This is also 1 here. Okay, 0, and then the column value is 1 again. Okay, so we have this situation where the port output port has values 0 1 1 1, right? And the column read by the microcontroller is 1101. So the question is which key is pressed. So first we will see, because this is the zero column, so we have to see it can be I okay, I made key, this one is okay. So which one, if this one is 0, it means, and this one is 0, so under this junction we have key switch 2. So key, if the key switch 2 is pressed, then this 0 ground value will make this 2.20 and the rest of the, okay. So it means that under this condition switch 2 is pressed. Next question, rows, if the rows value is 1011, rows value is 1011, okay, rows value is 1011 and the column value is 11101110. Okay, now find which switch is pressed. Of course this 0, and the in this row this one is 0, so this 0 is making uh, this 2.320, it's making 2.30. It means switch 7 is pressed. Okay, hope you understand. Take care, love is